Welcome to Season 1, Episode 1 of Science Forecast, broadcast directly out of Indiana University here in Bloomington, Indiana. Today, we're taking a look at a map of the world overlaid with global scientific collaboration patterns. Every time two researchers collaborate, it creates a link. The more collaboration between these two researchers, the thicker that link becomes. We can see this density in the US, Europe, and Asia. Let's take a deeper look into the United States. We can see this densification along the West Coast. A lot of here along the East Coast, we have Chicago, and here we are in Bloomington, Indiana. Let's zoom back out, take a look at activity in Europe. Fueled by the European Union and other funding, many researchers are collaborating across countries and across different disciplines, creating a lot of activity here. Let's take a look at a different data set. This time we're looking at Twitter, still looking at Europe. Each dot is a tweet, and the colors represent different languages. We can see in the Netherlands we have light blue for Dutch. Other major urban areas include Paris, London, Madrid, Berlin. A lot of activity in those areas. Our guest in studio today is Johan Bohlin. He's using this global Twitter data from you and from me, our friends and family, and people all around the world to predict human behavior. Let's see what he has to say.
Johan, thank you very much for joining us today. I wanted to start with the first time I heard about your work was when you published a paper saying that you could use social media in order to make predictions about the stock market. So tell us a little about that.
Yeah, that was a result of a year-long effort to look at how the mood state of the public could be gauged from social media data. You know, there's hundreds of millions of people on Twitter. They're telling us about their lives, their life's experiences. They're telling us how they feel as well. And so we're aggregating that data to derive some kind of barometer for public sentiment and public mood states as it changes over time. For example, it could change before an election, could change on behalf of a variety of economic conditions changing, the markets collapsing, etc. And that's when we started to correlate the mood measurements, the collective mood measurements that we're performing on the basis of large-scale social media data to the market. And that's when this one moment happened when my student walked into the office and says, "I'm sorry, we couldn't find a correlation between the markets and public mood states." And I wouldn't believe it. I said, well, it's really odd because when the market crashed in 2008, I was very sad. Right? And so she came back to me and says, no, you don't understand. The correlation doesn't work that way. It works the other way around. And so that inspired us to start verifying whether this effect was actually true. And since then, we've been looking at correlations between not just public mood states, but also investor mood states and the mood states of particular communities and how they correlate to a variety of socioeconomic phenomena.
And so does this information actually allow you to make predictions about, in the case of the market, what the market's going to do?
Yeah, it does. Well, I mean, it's difficult to say, you know, when are you actually predicting, right? Because people are all going to say, well, you're right yesterday, will you be correct tomorrow? Right? So the standard there is very high. But I will say that the kind of things that we measure in public mood state are predictive in nature. Mm-hmm. For example, if you're thirsty, there's a high likelihood of you drinking, right? And so if we could measure whether you're thirsty, we could predict that you might be more prone to drink something in the near future.
Tell me a little bit about the data itself. I guess you need a lot of data to do this?
Yeah, this is a very large, this is what they call it big data, and I think that's a silly term because, you know, whatever used to be called big data 10 years ago is small data now. So, you know, whatever we call big data today will be small data tomorrow. But there is a qualitatively different aspect of this kind of analysis in the sense that we've got 1/7 of the world's population on Facebook right now. So you've got the coverage of the world's population, and not just in terms of the number of individuals involved, but also the detail to which they divulge the most personal details of their lives in public, right, has fundamentally changed. So we're literally talking about data sets that are on the order of magnitude of 500 million tweets per day, 1 billion people on Facebook. We're talking about large swaths of the world's population engaging with these social media environments on a daily basis, and sometimes many different times on the same day.
And how do you get the data, or in what form do you get the data?
Yeah, that depends. But you know, these social media corporations, if you can call it, if you look at Twitter or Facebook, of course they realize the value of this data, so they sell it. And you know, the product is not Facebook. The product is you. I always make that joke. A lot of people don't realize that television is not in the business of broadcasting shows. It's in the business of selling your eyeballs to advertisers. And social media is no different. So they do collect the data. So these are essentially computer files. And they make those available to people willing to pay the price. And then, for example, you've got DataSift and GNIP. And they're resellers of that kind of data, authorized resellers. And if you've got a startup or a business, you can essentially pay them and they will provide access, streaming access to that data.
And do you have a selection bias problem? I mean, people who choose to be on Twitter and Facebook as opposed to people who don't?
Yeah, you do, but I think it's a lot of people refer to that and you're saying, well, you can't capture anyone who isn't on Twitter, right? But if 1 billion people is on Facebook, that's 1/7 of the world's population. So sure, there's a self-selection bias, but you've got nearly the entire Western world covered, right, in terms of participation in these social media environments. So there might be a selection bias, but I think the selection bias is manifested more in what we're willing to share about ourselves in these environments. And so far, research has indicated just about anything. People have very few qualms about divulging the most private information about themselves in these environments because it's social media. You think you're being surrounded by your friends. And I think that opens people up a little more than normally they would be if they would be standing on a market square and shouting personal information into the ether,
Right.
so to speak. Right. Yeah.
Right. And so the type of data you get from Facebook then, is that the complete set of Facebook posts? I mean, is it filtered in any way?
Well, for Twitter, at least, they do have a certification program, but if you pass the certification program, you pay enough money, you can get access to what they call the fire holes, and that's a real-time streaming feed that contains just about not just about all tweets generated at a particular point in time.
And how about with Facebook?
Facebook, I'm not so sure because we don't work with Facebook
Right.
that much. I think they're a little more protective of their data.
So this is more than just theory. I mean, you've gotten a patent on this, right? You've got a company that's doing this. Can you just tell us a little more about the practical applications of it?
Yeah, the practical, in this case, the startup has licensed the technology from Indiana University because they own the IP. It's a nice license. I mean, IU has been very kind. They're also, they hold stock in the company as a result of that arrangement. And what the startup does is essentially that it pays GNIP or Twitter in this case for their feeds. They're absorbed by our computers. It's all cloud-based. They parse out all of these tweets, perform this kind of analysis, and then we make the analysis available through a number of platforms. One of them is, for example, a dashboard like this, where investors have something similar to a Bloomberg terminal. But in this case, it's focused on these kind of predictive indicators that are generated by our computers. But there's also an API where, for example, hedge funds involved in algorithmic trading can hook up their computers to ours, and then the computers do all the work. They talk to our computers, they get the data back, and they automatically trade accordingly.
How about in healthcare? I know you've been doing some work as well in trying to, with applications in public health. Do you want to explain about those?
In our case, what we're interested in is mental health. Because a lot of mental health is associated with mood disorders. For example, depression, bipolar syndrome, etc. Those are mood disorders. And since these algorithms are fine-tuned to measure mood over time, you can look at individuals over time, chart their or track their evolving mood state over time and try to find precursors to depressive episodes, potential suicidal ideation, those kind of things.
Okay, so down to the individual level. In other words, we started with massive volumes of data looking at the behavior, say, of the stock market, but you can actually look at an individual and see what that individual is experiencing in terms of ups or downs in terms of mental health.
Yeah, that's kind of the idea. I mean, that's what this graph shows. It's essentially a user that at one point in time on Twitter publicly announced that they had been diagnosed with bipolar disorder. Then our computers picked that up. We took the Twitter handle, downloaded all of the tweets that individual had submitted to Twitter over the past 2 or 3 years. And then our computers went to work looking at every single tweet, looking for indications of a particular psychological mood state that was evinced by the wording of that tweet. And then you can chart that over time. You end up with a timeline like this where you can clearly see that this individual went through episodes where their mood was a lot more manic and had much greater variance, and then very silent periods where presumably they might have been more depressed. And so this kind of data, we can train our algorithms on this kind of data to detect the precursors to transitions to these kind of mental health episodes, and potentially could use that as a very large-scale monitoring system where you're looking at individuals or groups of individuals, and where the computers derive, I would say, warnings or sort of potential early warning signals for either that individual or that group of individuals transitioning to a new mental health state.
And then once you find patterns, whether it's at the individual level or at a more macro level, is the thought that you'll be able to go look for those patterns so that even if people aren't providing all of the other information, you can recognize that pattern from the
Exactly,
behavior?
yeah. I mean, it sounds really Orwellian, but that's not the intention here, because this is public data. These are people that voluntarily wrote these tweets. Of course, the fact that we can find the hidden signals in those tweets is really interesting, right? I mean, the wording that we choose on a given day to describe how we are, right? I got up this morning, this is going to be a fantastic day. That doesn't necessarily mean you feel great. That
Right.
could actually indicate that you're trying to perk yourself up a little bit because you're not looking forward to that day. So the computers can learn especially when there's enough data, they can learn to detect these kind of hidden signals that are even hidden to the individual themselves. And if we could leverage that to make advances in public health, for example, in actual interventions, that would be very worthwhile, because the data's out there. And these are people that, like little human sensors, that are reporting about what's happening in their lives and the lives of others.
So where's your research going next? What are you looking at next? And
Well, you know, honestly, recently I've been thinking about sort of this whole interplay between, you know, so everybody's talking about networks, right? That's a really hot topic. Here at IU, you know, we founded a network institute that has sort of world-class researchers working on the topic of network analysis and what it can do for society and what it can do for science. But I've become really fascinated by this interplay between the topological structure of the network, so what the network looks like, and what the nodes of the network look like. So I'm on social media, for example, right? And so you can tell who my friends are and what my social environment looks like. But the biggest mass of data that is out there really pertains to me as an individual. So this is the notion of the quantified self. So what I'm really interested in is, I think that the preponderance of data right now is not us knowing that we're connected on social media. That's a social connection.
Right.
But knowing things about myself as an individual, you know, what I've been eating, how much sleep I've been getting, how I feel on a particular day, whether I'm planned to travel, you know, how much money I'm spending, what am I spending it on. All of that information pertains to the individual. So I think that what I'm really interested in is using network science to learn more about the individual and helping individuals learn more about themselves. And this is a good example of that, right? I mean, I could analyze my own timeline, look at it and figure out that, you know, perhaps I should be getting out and getting a little more sunshine and, you know, going for a run from time to time, not working so hard because it's really depressing me.
Right. So where, if you had to think about data sources for the future, I mean, who would have predicted Twitter, you know, 15 years ago, or Facebook for that matter? But do you envision entirely new sources of data?
Yeah, absolutely. I'm actually a big proponent of, well, it wasn't called a proponent, but of the notion that wearable computing is going to be big.
Right.
So this whole notion of the Internet of Things. And that automatically means that there's going to be more of an egocentric aspect to the data. You know, if you look at the iWatch, apparently, you know, it was going to be instrumented to measure your pulse and potentially your blood pressure. I know that the oxygenation of your blood can be measured like that as well. So we're going to have a whole bunch of sort of physical, emotional, and psychological measurements occur in the next 5 or 6 years that are essentially generated by the computers that we wear on us, that we interact with in sort of our physical reality. So it won't be something that I'm going to go to the Twitter website and I'm going to interact with Twitter. This is where I'm going to be interacting with the network continuously. That will be an essential component of who I am and what I want to be. And I think that that's where most of the data in the future is going to come from. There won't be these sort of carved out social media environments that we actually have to go to and that would have to be lured into. This will be data generated by our environment, by the chair I'm sitting in, the watch I'm wearing, the glasses you're wearing, not just the cell phone, just about anything that we wear on our bodies that will help us to live.
Seems like all of these data are going to be almost intrinsically, whether by consumer choice or by industry choice, linked across national borders as well.
Yeah, I've got a colleague at the School of Library and Information Science actually working on, you know, connecting different social media environments. For example, Sina Weibo is very common. It's like the Twitter of China. But Twitter is banned in China.
Right.
But Twitter isn't banned in most other countries in the world. But Sina Weibo, because it's a Chinese environment, is not quite as accessible. And so he's working on algorithms of connecting thoughts and ideas that emerge in these kind of environments independently, but then allowing the computers to reason about it and say, well, you're really talking about the same actor, just in a different language, in a different way, but it's the same concept. And it relates to all of these same concepts, these other concepts in the same way. So you effectively are bridging languages and cultures through computational thinking, through computers, through machine translation, and the kind of algorithms that we're working on.
But it's exciting to hear you describe it, because it seems like both at the high level, at the macro level, at the potential for things like medical research, for fighting terrorism, for making money, for doing all sorts of things, but also at the individual level, that the data might actually be used in ways that would make predictions or would facilitate making my own life easier or better or longer, if you will.
Yeah, hopefully not just easier, but better as well. Right? But yeah, you'd hope that big component of that would be that it would make you freer as well. Right, and I think that in terms of the societal discussion around this data, we haven't yet figured out whether that's the case. You know, if you look at, for example, social components of these discussions, I'm really concerned about sort of, well, let me put it this way. I think that people become more empathic if they know more about other people. Right? It's the whole idea, if I walk in your shoes, it would be really difficult to dislike you, because I would know what it would be to be you, right? So I think in that sense, social media is bringing us closer together, because we understand more about people's conditions, about how they live their lives, what they care about, and it turns out that they care mostly about the same things we care about. So I think in terms of sort of a global understanding, sort of a kumbaya moment, social media has become a really useful tool for that. But at the same time, you also have the sort of the flip side of that, the dark side of that. You've got public shaming. You've got people, becoming really upset about, strategically upset nearly about what people say. You've got a whole culture dedicated to being angered, strategically angered by people using the wrong words or phrasing things in the wrong way. And so then we're back in sort of a small village where gossip and rumors and are being used to destroy people's reputations, and where the entire environment becomes a little more restrictive to personal well-being and freedom. And so my hope is that the algorithms that we work on will have more of the former and less of the latter.
Well, I hope you succeed. Thank you again for joining us.
Thank you. It was a pleasure.
Interesting, isn't it? Maybe one day there'll be an app for all of this. It might change when and what you tweet. This is a map of science where continents are not America, Europe, Asia. Instead, they're disciplines of science. We have math and physics in purple, medical specialties in red, and social sciences in yellow. You can see the overlap between all these different disciplines, and the push and pull is created when new links are generated between the different disciplines. Let's zoom in now on medical specialties. Just heard our guest, Johan Bolen, talk about mental disease, and it is found in this medical specialties area. Next time on the Science Forecast, we're going to talk about the funding and the research in this area. Stay tuned. Thanks for joining us today.
When that door slammed shut, something changed inside of you. Something you can't control. Find out what happened now on Science Forecast.
Today's episode of Science Forecast is all about sound. We'll hear from Indiana University Associate Professor Rob Potter, who's part of a global network of audio researchers stretching from Dubai and Dublin all the way to Bloomington, Indiana. This map shows us where these researchers are working around the world. Studies cover everything from language to music. They look at concepts like how certain audio frequencies can spark certain responses in humans, and how well people can remember things that they hear versus things that they see. Potter spent years as a radio personality trying to figure out what makes his listeners tick. Here in Bloomington, he's researching how people respond to different sounds. With all of the distractions that we see every day, it's hard to keep our attention. For example, how can you captivate listeners of a radio show when they can't actually see anything? Rob Potter's work is just one part of all the scientific research going on around the world. This is an atlas of science where shapes are not continents, but areas of research. We have math and physics in purple, medical specialties in red, and social sciences in yellow. You can see how these disciplines overlap. The audio research in today's episode falls within the social sciences block, but also shares a connection with other areas like brain research. Potter has studied questions like this since he was in grad school, and when he's not studying audio, he's performing it.
Rob Potter's instrument of choice is the mandolin, and his band, under new management, is made up of 6 members, 5 of whom work at Indiana University. They come together and play every other week. From studying it to performing it with friends, audio has always been a part of Potter's life.
Coming up in the next half hour, I'm going to tell you a way to win great tickets to the Lil Wayne
He was a
concert.
DJ for several years and then transitioned back into audio research.
I missed being in the classroom where things can change every day, and they do change every day. And so I had the opportunity to go back, and I took it.
The research happens here at Indiana University in Bloomington, on the 6th floor of Eigenman Hall. Shown here are a few of Potter's grad students simulating how the research was conducted. Ariden Van Driel and Jingjiang Han are using the heart rate and EKG monitors while Anthony Almond and Potter watch the levels in back. During his time as a graduate student here at Indiana University, Rob Potter worked with his dissertation advisor, Annie Lang, on reactions to visual stimuli. Together, they tested visuals with added voice changes, added sound effects, and added keywords to elicit a response. From this research, Potter found a growing interest in response and auditory stimuli, something that was done infrequently compared to visual responses.
Is activating, so we use this as a measure of.
Potter's work has been published in many academic journals.
I can think of 2 or 3 professors across the world who look at audio in media from a cognitive standpoint, the way that I do.
Today, Potter's recent work involves measuring orienting response to voice change. More specifically, he is focusing on reactions to changes in radio advertisements. An orienting response is something like the change in your heart rate or how much you sweat.
I mean, the cool thing about studying media or researching media is it's always there. It's something that we use each and every day, and it's also always changing.
Rob, thank you so much for joining us today. Tell us a little about your work and what have you learned about the effect of audio changes on cognition and physiology?
Well, it's great to be here. I've started this work about 20 years ago when I transitioned from being a full-time radio disc jockey, where we used a lot of intuitive knowledge about how audio captures people's attention. And then I went to grad school and found out that there are tools that you can use to actually test or confirm this intuition about what gets listeners to automatically pay more attention to a radio commercial, for example. And so what I look at is these changes in the auditory environment. So if you think about a commercial as an ongoing stream of sound, right? And then what is it about that ongoing stream that introduces new things in the listening environment?
So then tell us about this experiment. How did you set it up?
We literally, actually not too far from here, sat in a lab and made a list of what do we think introduces new things to the listener's ear when you're listening to a radio program. So we said, well, when 2 people are talking, right? If my voice is replaced by yours, then that's actually a change in what the listener hears. And actually that was the first place we started. We made a list of voice changes, the onset of jingles, the onset of funny voices, maybe the onset of certain types of words, like words that invoke danger or fear, or words that evoke the human biological being to move forward, like sexual content or what have you. So we just made a list of all those things, and then we went and found them. So we made an awful lot of audio tapes. This is back in the cassette tape world. And so we made a lot of audio tapes and then found the little pieces that we wanted that we could then put together as if they were one show. We played it for listeners, and we actually then measured the things that your body does when it has this orienting response, this what is it response. So one thing that happens, and the things that I use the most in my work, is your heart rate decelerates for about 3 or 4 beats, which then translates into about 5 or 6 seconds, right, across people. So if you actually then say, well, what happens when Rob's voice is replaced by Fred's voice, if we find that moment in time and then see what happens to the listener's heartbeats at that moment in time, then you can see whether or not the orienting response occurs.
So tell us about some of your results. So for example, why don't we start with the funny voice example that
Okay.
you used?
So this graph is actually showing there where it says onset. That's the onset of the funny voice in a commercial.
Right.
Okay, and this is multiple people having listened to that funny voice, and then the 6 seconds afterwards. And what happens to their heart is that it does do this nice deceleratory pattern. If nothing particularly important happened there at the moment of onset, your heart at this moment in time, right now, when nothing remarkable is happening, yours may be accelerating, mine is decelerating, that camera person's is doing a little bit of the same. If we take this average, we'd get more or less a straight line. When something remarkable does happen, everybody's heart goes, whoa, and decelerates. And I think we actually do have an example of what a funny voice, not the funny voice, this is an example of what one might be.
Yes, it is, Mike.
Not too much, Zoltan. I wouldn't want you to explode on me. And
Mike, please, I'm a pro.
Zoltan, you're
So that's actually multiple auditory structural features there. So they've used the voice change back and forth. So there's one person's voice that then changes. It just so happens, in this case, it changes to the funny voice, the guy with the helium. And these are things that, again, when you are a copywriter trying to say, how are we going to capture people's attention and cut through the clutter of messages that are out there, very creative people come up with this intuitive sense that, well, people, you've done this at parties. You take, the helium and then you talk like this. Well, let's put that in. Well, now we can actually empirically show that that does work.
So now you also tested a commercial, and there was some surprise in this, right?
So everything that we've played now have been examples of the onset of a commercial. Right. What isn't surprising is that because it's essentially the onset of something new, you do see this deceleration in the heart rate. That wasn't a surprise. But what we haven't talked about yet today is the difference between attention and memory. So you can actually pay attention to things to a greater extent, but then that doesn't necessarily translate into better memory for it later on. What we predicted initially in all of these is that because the orienting response is the allocation of more attention, that would then mean you would get better memory. Right. So if you look at what happens before the onset of this, and you compare memory for that to memory what happens right afterwards, you would expect it to increase. That happened in all the other structural features except for the commercial. So what happens is the memory for stuff before is better than for the memory immediately after the commercial starts. And that surprised us a little until we said, well, let's look back again at the Lang work and the Reeves work. They actually found that if the camera change was what they called at the time a related cut, so a cut from the two of us to a cut of you, that's related and expected, and in fact, the memory is better after that cut. But if I said, I wonder what's happening at the IMU, and then they cut to a picture of Chicago,
right,
that's unrelated, and memory after that gets worse. So what we have here is we have actually the onset of an unrelated audio cut.
So now I can see why advertisers would find this type of work really interesting and important for what they do. Are there other applications? Are there other people who should be interested in this work, and particularly its impact on memory?
First of all, part of the reason that the media school has been created, I think, is to increase a sense of media literacy. So I think actually the more we can understand just as media consumers about how these things, again, affect us as psychological stimuli, though people don't think that way, but right, if we can think about, well, what is this show doing to me as I watch it, I think there's benefit to that. Right. There's also benefit from the auditory stuff when you think about how often radio is used as a way for first responders, for example, to communicate with one another. So if you think about a dispatcher trying to communicate to a firefighter in the field, are there ways that we can have those voices be optimally matched so that greater attention is paid, so that it's easier for the person in the field to understand and make sense of and remember what they're told? That's one possibility application for this, and a pretty exciting one, I think.
So what are you doing now? What's next on the horizon for your research?
I'm continuing to look at the changes in voice changes, in their accents, if you can have differences in topic matter across the two speakers. That's one of the things that I'm working on. I'm also starting to work more and more with graduate students who are interested in music, and how can we take the things that we know from auditory structural features in commercials and apply them to music. And of course, with the Jacobs School, IU has a great set. There's collaborators all over the place that we're finding who want to help work with us on this.
That's terrific. Well, Rob, thank you so much for
It's
joining us
been my
today.
pleasure. Thank you.
Excellent. Thank you.
It's not every day you see a DJ turn into a university researcher, but Potter's radio background has really helped him in his studies. This all goes to show that people don't need to come from traditional backgrounds to come up with exciting and innovative research. The next scientific breakthrough can come from anywhere and from anyone. So tune in next time to Science Forecast to see what comes next.
Sami Marif,
Brian Bruce, Kyle Englert,
James Freeborn,
Emma Harrison,
Ben Houston,
Nikki Kofkin, Sydney Liu,
Craig Lyons,
Kelly Obi,
Ty Patterson,
Jessica Smith,
Kale Wilk,
Jessica Witzak,
Bhavish Anand,
Bonnie Layton.
No matter what you do, guns, no guns, it doesn't matter. You have people that are mentally ill.
Bring mental illness out of the sheds.
What is the relationship between mental illness and violence?
The shooters in Tucson, Arizona and Aurora, Colorado are believed to have significant mental problems.
That tragedy could have been prevented had our mental health system been in better shape.
Stigma still is a very big issue.
Many people believe those suffering from mental illness are likely to be violent and dangerous. But how much of that is stereotype and how much is reflected in the actual research? We'll explore that and other questions related to mental illness in today's episode of Science Forecast.
Thanks, Jim. Today I'm going to be interviewing Dr. Pesco Solito in the studio in Franklin Hall. Let's see where she is now. Dr. Pesco Solito has been teaching at IU since 1981 and earned the title of Distinguished Professor in 2006. She has been the co-director of Indiana University Network Science Institute since 2013 and is also on the Committee on the Science of Changing Behavioral Social Norms. Before I sit down with her, let's hear from Jim about her research focus.
Dr. Pesco Solito has received more than 90 grants from a variety of sources. For example, in 1995, Dr. Pesco Solito was awarded $150,000 from the MacArthur Foundation. This grant funded a study that showed the public's association between violence and mental illness had grown significantly since the 1950s. From 1998 to 2014, she was granted over $11 million from the National Institutes of Health. These grants funded several studies examining the relationship between communities and the outcomes of mental illness, particularly suicide and mass shootings. Spanning over the decades, with grants as varied as her research, Dr. Pesco Solito has received just over $17 million. This is a map of science where continents are not North America, Asia, and Europe. Instead, they're science disciplines. You can see the overlap between these areas. A push and pull is created when new links are generated between them. In each episode, we'll explore a researcher's work in one of these areas. Dr. Pesco Solito's studies are concentrated in this region, but as you'll see, they cross over several disciplines.
Dr. Pesco Solito, thanks for joining us today. We're going to focus on your study of stigma and mental illness. Why did you decide to do this study?
Well, I actually stumbled into it. I was interested in pathways to mental health care, and I was thinking about how the models that exist seem to be very individualistically oriented, very static, very focused on how people weigh the costs and benefits in their head. And two things occurred to me. The first is I didn't know anybody who made their decisions that way. And the second thing was that certainly the issue of mental illness interferes with cognitive functioning. So why would we use that kind of model to understand how people are trying to interpret different kinds of behaviors or thoughts or feelings that they have? And so once I had established that model, I started thinking, what's in these networks, right? What is it that people tell each other? And I, as a classically trained sociologist, my first thought went to Irving Goffman and his classic study of stigma that took place in St. Elizabeth's Hospital in the 1960s. And I got into the literature and I started thinking about it, and I found that we hadn't had a national study since 1950. And I called an expert at Columbia University, another sociologist named Bruce Link, and I said, is this true? And he said, yes. And I said, we have to fix this. So that was the beginning of trying to understand stigma in contemporary America.
Awesome, thank you. Can you explain a little bit about how the study was carried out?
There have been a number of changes, some for good and some for bad. The most important change I think that we've seen is that Americans have become more sophisticated about mental health. They name many more types of disorders that represent good mental health and mental health problems. They also are more open. I think this was our most significant finding in terms of change, was that Americans have become more open to talking about and disclosing their mental health problems. On the bad side, however, one of the questions just asked them spontaneously to say what mental illness is. And one of the things that we saw was a dramatic increase in the number of Americans who spontaneously mentioned violence as part of mental illness.
You mentioned that Americans, our categories of mental illness are far more broad than they were in the past
Yes.
compared to the previous study. Can you tell us a little bit about drug and alcohol addiction, which you included in your study, and why stigma continues to persist against those two things?
Americans are much more negative toward people with substance use disorders than they are to people with mental health problems. And that was a surprise given the severity and the standard stigma associated with schizophrenia. The other was that for the first time, we saw things moving in the wrong direction. Right? So that it was only with regard to alcohol issues that we saw that moral attributions went in the wrong direction. In other words, with regard to depression, schizophrenia, we saw that people have bought into, or they understand the role of genetics, they understand the role of chemical imbalance, or what we call the neurobiological explanations. And we've almost reached a ceiling in the United States in terms of people saying they understand that. But look what happens with regard to alcohol. We see a dramatic and statistically significant jump in the percentage of Americans who mention that alcoholism is really due to bad character. So while the disease, like any other tagline, is working for mental illness, it is not working for substance abuse disorders in the U.S.
Why do you think in general that people are increasingly associating violence with mental illness?
Well, I hate to say it to you, but I think the media has a big role in this because the research is quite clear. The research that was done by the MacArthur Law and Mental Health Network has shown that if you take the crimes committed by people with mental illness out of the American crime rate, you're left with 96% of the American crime rate. And we also know that people with mental illness are more likely to be victims of crime than perpetrators of crime. But, you know, stereotypes continue to exist because there's always a little kernel of truth. And it is true that individuals who are in active episode, who are comorbid with alcohol or drugs, are more likely to be violent. But that's a very tiny group of people with mental illness.
Do you have any predictions for next year's study going forward?
Oh boy, that's a great question. Well, I think that we're concerned, we're hoping that the amount of effort that's being done in America for anti-stigma campaigns, and also I think the attitude, the very positive attitude of the millennial generation, I'm hoping that that will begin to show up in lower levels of stigma than we saw in the comparison between 1996 and 2006. So I'm hoping to be pleasantly surprised.
Can you tell us some of the things we can do to change stigma just in our daily lives?
Well, I think the thing is to recognize that everybody has something that they struggle with. and that people with mental health problems are not dangerous unless they're comorbid with alcohol abuse or with drugs, and to be more inclusive of people who are different. And I think that the way that we want to proceed here at IU, because we are doing the national pilot study for colleges and universities to create a college toolkit to make college campuses safe and stigma-free, that what we're trying to do is have everybody think about difference and how difference is something that should be celebrated rather than stigmatized. So no matter what it is that makes you feel different, if you can accept it in others, then maybe you can accept it more in yourself, because college students are at peak age of onset. They're also facing new stresses. They're often the first time away from home. Their social networks are dramatically shifting as they move from their hometowns to a large campus like IU. And this is a time when they could start to understand their anxiety, their stress, their depression as something that is not normal exactly, but it's expected. So hopefully if people understand that there are natural ups and downs in people's lives, that for some of us that will mean that we'll dig a hole, or we'll get a hole dug for us that we need help getting out of. And that doesn't make you crazy. It makes you a person who's dealing with important stresses.
And those things can all help us change stigma going forward.
I hope so.
Absolutely. Thank you
Thank
once
you.
again, Dr. Pesco-Salido, for joining us here today.
Okay, thank you.
As you can see, Dr. Pesco-Salido's 30 years of research integrates findings from across several fields, from the area of health professionals, brain research, medical specialties, and of course, social sciences. Thank you for joining us on this episode. We look forward to bringing you the next episode of Science Forecast.
Hello, we are very excited to join you again for the last 20 minutes of this 24-hour event of 24-hour science map event. Who you already know, but I'm going to let my friend Jasmine introduce herself and tell you a bit more about her.
Me, and right now I'm in astronomy and astrophysics. Right now in my major, I'm doing a lot of physics and math, and it's pretty difficult, but I'm in my second year right now and I'm getting through it. I believe Ellie here has something crazy to tell you about her major, something crazy.
Beginning of this whole event, I said I was a chemistry major, which isn't totally true anymore because I just recently changed molecular life sciences. Biology is awesome, but also it shows just how interconnected all these different fields are, and how it's cool to just like find where you belong in giant world of chemistry and science.
Okay. So today we'll be announcing 3 winners for the contest that was happening. They were going to win some cash prizes. So third place is going to start at $30. Oh, I'm sorry. Second place will start at $70. First place will get $100. So that's pretty big.
Not about the money. It's all about the awareness of science. And we're really glad that we could also just combine science and artwork. Because I believe that those should be more interconnected, get like swamped down on all the data and just focus on what you're learning and write a lot of papers. Mix it in with art and stuff, makes it a lot more easy for the general public to understand it, and also just a lot prettier. And I think making data and stuff beautiful is really important for everyone.
So here you're looking at a pie chart. It has all the ages of the submissions that we've gotten. You can see there's like 28.6% is 11 through 20. We have 14.3 both for 21 through 30 and 51 through 60. And then we have the biggest age, which is 31 through 40 with 42.9%. So it's pretty interesting to see that.
glad that are the people that submitted were of all different ages and also from a lot of different places in the world, which is really cool. Announce who the winners were.
So in third place, drum roll. Woo. We have Monica Herzig. This is Monica Herzig. Yes, she is my mother. We have the same last name. You can see in the photo, she is a musician. I think you guys heard her play last night at 10 p.m. She was doing her little improvisation with her numbers. I think it was the pi, so 3.1415. So she introduced how she can use numbers just to make a cute little ditty, a cute little song. It's just a photo of her she posted on her Instagram at Monica Herzig. She is sitting at her keyboard, smiling at the camera. It's pretty artsy because you can see a self-portrait in the background. There's elves. It's a pretty cool setup. Little birds on the wall. For getting in third place, she will win $30. And congratulations to Monica. Yay.
Winner is, you don't have two hands. David, who's from France, who's really cool. I've never met him, but he's really cool. Here's his video. He was able to take data from Twitter. As we all know, there's so much data and so much stuff happening on Twitter. And he's talking about COVID-19, which there's also a lot to be talking about. And politics, which interconnected politics. We have data visualizations to show how they're connected. How people are viewing it, which isn't always the same, but it's very interesting seeing it. Beautiful music that goes along with it. You should really check out this Instagram post and his website there that you should also check out.
So that was our second place. And at the bottom, there has his Instagram. So I don't know if you can see that, but if you want to look him up, he's going to get $70 for winning second place. Yay. Okay. All right, now it's time for the first place winner. Yay. Okay, so this is the World of Scientists. So she won $100 and she made this cool map. Want to say her name?
Miss Vu. Miss Vu made this gorgeous artwork. My parents also know her and have seen her art. It's very cool that we got to get this art piece for this competition. She's from Austria, which is really cool. And yeah, as you can see, it just got a lot bigger behind me. Yeah, take a few seconds and talk about it because we thought this was very inspiring and as college students, relatable.
On this side, I don't know if you can see that we have reviewer shark, little sea of sharks down here. They're looking kind of angry. These are the reviewers and they're the critics of. Then we go up to Deadline Jungle. There's a bunch of skulls, palm trees, like islands. Then you can see a bunch of skulls, so it looks like there's a bunch of dead people here, like Deadline. It's interesting because just above it, there's like a happy island, the sugar magic forest. So it's rainbows and lollipops and ice cream, cotton candy, and it's just super happy. And you probably get a big sugar high on being there. But then there's caffeine lakes, because you always need your caffeine as a scientist. We got the idea factory. So we have our little bottles, little potions over here. Let's see what Ellie has on her side.
Cool stuff over here too. A lot of evaluation, and I feel like I'm constantly being evaluated. And I feel like when I start writing papers and grants, that's not going to go away because people are constantly evaluating us. science, because if we didn't get evaluated, some of our science might not be peer reviewed. It's what makes science really important, because it is a source that you can trust because of all the process it goes through. We also have procrastination field, which is so relatable. It looks so nice to just lay down and butterflies, which is interesting, right? Bomb field, which is a lot less peaceful looking because it's a bomb field. Up here above procrastination farm, there is supervision zoo. I think that's what it says. Supervision zoo, which has all the animals. I'm more of a cat person myself. What about you, Jasmine?
I only live with my cat right now, so more probably leaning towards cat person, but I still love dogs. They're great companions. They're just a lot to take care of.
Yeah, I can see that. Going over something that we can both relate, collaboration. Aren't we collaborating right now? Important to keep in touch with everyone else in science and not just get like huddled in your own area of science. You have to like look out and see what all the different other fields are doing too, so that you can stay on top of your research and know what's going on in this world. Then there's the I am nowhere valley. Just kind of depressing. Okay. Never give up. Lighthearted. Up even when you are in the funless maroon monsoon, not maroon. Yes, you're right. Monsoon.
I saw maroon too.
Yes. And then lastly, this. Can you help us, Mom? What does it say?
Mission vortices. So oftentimes you get something rejected and then you reformat and resubmit, or you just try to get the funding that you think will really make a difference. All right, well done.
To say thank you to our whole staff. Everyone's been super. We've had to all work really hard to make this event happen, and I'm so proud it's done with. Well, not done. I mean, there's still so much more going on, but it's been 24 hours and it's stuff.
Amazing job with the website. I think everybody was asking, oh, who did this website? And I'm like, yeah, it was my daughter. So thank you for that, Melanie. And there were a lot of changes also. And then so it's nice to see it all. All right. I would also like to thank Ellie and Jasmine here on the stage with our masks. And I think they have been watching out on the contest for all of it. And also haven't they been doing a good job announcing the winners, and personal congratulations to all of you. So we will send out those cash prizes, and thanks for submitting. And it's really, really nice to see so many submissions come in. All right, next one.
Zachary Herzig and Ella. Zachary is my brother. Ella, I think Ellie
was a very big part of our social media campaign and helped bring out awareness. She's the one that made all the cute little squares that you've been seeing around our Instagram accounts, and that's been being posted every day by my wonderful mom. She doesn't really know how to post posts now. So that's awesome. They've been very supportive and very nice to help out, and we just love having them on our team.
City Canova, she was a trooper and hero. She did the night shift. So she came on at midnight and guided all the speakers through till 6 o'clock when Todd Theriault took over again. Medina, thank you for all. And thanks also for all the other organizational parts that you did. And some of you might have seen Medina in the yesterday. Medina is very active in our science outreach. She hosts a lot of the makerspace events, and she also does a lot for just bringing maps to general audiences. Next are Martin and Tracy Theriault. Both of them have been instrumental in getting the word out and also social media. We had an entire Instagram team MIT Press gave us access to, so you might have from that as well. I don't know if he ever got to sleep in those 24 hours. It sounds like he didn't. So Dave, thank you for that. And I think there were a number of times when some speakers didn't have audio or couldn't see anything, and you always were able to resolve it. I don't know how you did it all, but thank you for that. And you kept us safe, no bombing. We also have Andreas and
here's our wonderful cameraman. He's right back there right now. Sadly, you can't see. This whole setup is amazing. All the lighting that makes us look so great. He set up, which is really insane. He's just been on top of it so much. He's been here this whole time. And we people helping with all the different stuff, which is just amazing. And yeah, we're really lucky to have him.
Next one is maybe for Jasmine.
So we have Monica Herzig for providing great music. So sounds like she you guys last night. Maybe her songs will be played later. I'm not sure. But anyways, you can always just search her up on Google. She's a known musician. She plays around Bloomington, around Indy, and you can always. She plays with multiple people. Sometimes bands, sometimes with their own husband, and we'll be playing as a family on Christmas Eve. So thanks, Monica Herzig.
Last but not least in this long list is MIT Press. It is a true pleasure to collaborate very closely with their team. As you know, the MIT, sorry, we have to cut this out. We will cut this out. Last but not least, MIT Press. It was a true pleasure to collaborate with the team at MIT Press for the last 20 years, because it always takes a while to get a book approved and then to go through all the movements it takes to actually get it published. It's really astonishing that we were able to get those books all in the same format and same style. And also the team here at Indiana University, including Todd and Tracy Theriot, were instrumental in making that work. So thank you also for letting us take over your Instagram account. That was really quite something. And then last but not least, I would like to thank all those which funded this event. And particularly, we would like to thank Maury Goldstone, who gave me a present. And I was thinking for a long time what I should do with the present. And then I thought, oh, why don't we use this present to invigorate all of us and the mapping of science by an event that's 24 hours, that's going around the clock. And I guess I talk too much, that's why you can't hear me anymore. But it's also supported by the Cyber Infrastructure for Network Science Center and supported by our school, the Luddy School of Informatics, Computing and Engineering. So thank you all. And I think we have to officially stop now because my voice is not doing it anymore. So thank you all. And bye.
Oh. Thank you, Kati, for being a wonderful host. Name on this list, but she basically organized, and it was just so cool seeing this. Very, of course, you saw all of her books. She's been so busy. She's constantly doing new projects and making sure that everyone sees the importance of data visualizations, and is just an amazing, inspiring person.
Yeah, it's actually quite fun. I recommend highly to host your own 24-hour event. It's demanding, but I think it's all worth the effort. And I think there was one question that was asked, what was all of it? And I think for me, it was that it brought all these different good forces together, all these cool young people which were helping with Instagram, were helping with setting it all up, and helping also with how this program could evolve and how it might look like if not only pioneers of data visualization get together and of science mapping get together, like the many, many talks you just saw. But generation comes to the table. So thank you all.